Hello everyone. So today I'm going to make another tutorial on x86-64 assembly programming. Today I want to cover global variables and conditional set and conditional move. So let's go over global variables first. So I'm going to create a assembly file called global.s. So um, as you recall, for every single program um, to declare the function, we have .text specifying that this is the text section that we're working in, which is the memory section where we store the code. And to declare a function, we type .global function name. In this case, the function name will be main, and then main colon, and below the colon is where we implement the content of the function. So every function should have push Q, RVP, move Q, RSP, RVP. And then at the end of the function where we return, we have to undo these two instructions. So leave is an instruction that undoes the push Q, RVP, move Q, RSP, RVP. And at the very end, we do return, which pops the return address off the stack and jumps to that return address. Okay, so for global variables can either be stored in the data section or the BSS section. So the data section is for storing uninitialized, the data section is for storing initialized global variables, and the BSS section is used for storing uninitialized global variables. So let's take a look at the data section first. We use .data to specify this is the data section. So to declare a global variable and initialize it, we first type the global variable's name. I'm just going to name it n, colon, okay, colon to specify its value. And then just type .quad 2 in this case, .quad because we're working with 8-byte registers, so I'm just going to make the global variable quad, and I'm assigning it the value of 2. Okay, so let's mess around and see what we can get out of this. So let's just try to simply print out the value. In that case, we would need a string. So let's define a string. String declared in the declared in the text section. And we simply want to print out the value of n. So we have that. And then to print out the value, we need to call printf. So recall that we simply move the address of the string into RDI, which is the register for storing the first argument. And then our second argument would be n. And we can simply do move q n, comma, and RSI, which is for storing the second argument. Since printf is a variadic function, we have to initialize rex to 0. And I will explain this in a future video about why we have to do this. So in this case, we're just going to print the value of n. So let's take a look. To compile the program, just use GCC. Okay, so I forgot the dash here. Dash static basically just means that it's going to use like constant memory addresses, which is easier to work with. Okay, so we see n is equal to 2 because in our program, we initialized n to be 2. Okay, so since n is an integer in this case, we could modify its value by using add q, sub q. So let's take a look at add q and sub q. Let's say I want to add 1 to n, then I simply do add q $1, comma n. And whenever dollar is in front of an integer like 1, that means that this is basically a constant, right? And here we use dollar in front of str to get the address of the string. So let's add q $1, add 1 to n. So this is basically n is equal to n plus 1. Okay. And let's try printing it. Okay, so we see that it works fine. N increased from 2 to 3 because we added 1 to it. Okay, so now you might wonder if subq also works, and we can see. So in this case, since we added 1 to it and we are subtracting 1, for this print statement, the value of n should be the same as it is here. So let's verify that. And we see they are the same value. Okay, so you might think that multiplication can be used in the exact same way. So let's say we want to multiply n by 2. Okay, so let's try this, see if it works. Yeah, so we get an error. It tells us operand size mismatch for IMO. But it doesn't really matter much in this case. We can just move this value, right? Move it into a register, move n into this register, and then we can do the multiplication on the register. And then we can get rid of it here, since we already moved 2 times n into the register. And we see it works. So 2 plus 1 is 3, 3 minus 1 is 2, 2 times 2 is 4. Okay. So I mentioned that in the data section is where we do the where we store the initialized global variables. So here we're specifically assigning the value of 2 to the global variable n. But in the BSS section, we kind of just it's for where we declare a global variable, but we don't assign a value to it. And we can take a look at what that would do. So for uninitialized global variable, just do .com, COMM, and then global variable name, and 8 bytes. So n is a long, basically. It's 8 bytes long. Okay, so let's see. Okay, so we see that it is initialized to 0, and global variables that are declared in C but not initialized will automatically be assigned the value of 0. Okay, and 0 plus 1 is 1, 1 minus 1 is 0, 0 times 2 is 0. Okay, so that's all I'm going to cover for global variables. I want to move on to conditional sets. So if we go down this cheat sheet, we see in this section 3.4 accessing condition codes, we can basically set the value of this destination register D to be 0 or 1 based on whether or not the compare queue results in the two values being equal or not equal or greater than, less than, right? Okay. So let's create a new file for this. Let's name it cond.n, short for condition. Okay, so Once again, we always have to have these lines in here. Okay, so we want to see how the set instructions work. So for the set instructions, we can set a single byte register. So let's use some registers. Since these are not callee state registers, we don't have to push them on the stack before using them. Okay, so we're gonna give RCX the value of 1 and give RDX the value of 2. And we're simply gonna compare the value of RCX to the value of RDX. In this case, it's very clear that RDX with a value of 2 is, of course, greater than the register RCX with a value of 1. But remember that the compare instruction, right, it's going to evaluate RDX minus RCX and compare it with 0. So the flags will be set on whether or not RDX minus RCX is greater than 0, equal to 0, or less than 0. Okay. So let's set 2 byte registers. So I'm first going to set it equal to, and a byte register is R8B. Okay, this would work. And let's set another one based on greater than. Okay, greater than, we will set R9B. Okay, so what this does is the value of R8B will be 1 if and only if RDX minus RCX is equal to 0. So that's what the E stands for. E stands for equal. And if they're not equal, then R8B should be set to 0 because the condition is false. And similarly, for set G, it will be set if R9B will be set to 1, which represents true, if RDX minus RCX is greater than 0. So the G stands for greater than. And if it's less than or equal to 0, then it will be set to 0 because it would be false. That condition would be false in that case. Okay. So let's print out the results. And to print it out, we would need to define a string. So we're just gonna define a string here. R8 is equal to this value. R9 is equal to, okay. Okay, so move the address of the string into first argument register, RDI. And then since these two are byte registers, but the registers are SI and RDX, which is for the third argument, they are 8-byte registers. So we need to, instead of using like move Q, which would fail in this case because these are only 1-byte registers, we need to use a command called move 0 extend from byte to quad. So quad represents 8-byte registers, and the B byte represents 1-byte registers. So we're going to 0 extend from byte to quad, which means the values of these two registers are not going to get changed. So whatever we move from these two byte registers into the 8-byte register, the value is going to stay the same. But it's 0 extended in the sense that we fill all the upper bits to be 0. So because a byte is 8 bits, right? And 8 bytes would be 8 times 8 equals 64 bits. So we're basically filling all the 64 minus 8 bits with zeros. And in that case, it would be compatible with an 8-byte register, but the value is still the same. So we're going to move R8B into RSI. RSI is for the second argument, right? Because in our string, we first print the value of R8, then we print the value of R9. Yeah, technically it should be R8B. I'm just going to leave it like that. And we do the same thing with R9B. And in this case, we need 3 arguments, right? So the string is the first argument, R8, that's going to be the second argument, and we need a third argument. So if you need a third argument, you need to use RDX. And then we're going to call printf, so move q0 to rex. Okay, so let's take a look at this. 20. Okay, so there's been a little bit of an error here. Oh, okay. I typed a $sign instead of a percent. I've TA'd for an assembly course before, and there was a student who would make that mistake. Make sure to be careful of that. Okay. Okay, so we see that the value of R8 is 0 and the value of R9 is 1. Okay, so what does that mean? If we go back to the code, R8 is set to 1 if and only if RDX minus RCX is equal to 0. So it's set to 1 if and only if RDX is equal to RCX. But clearly they are not equal because one contains the value 1 and the other one contains the value 2. Okay, so let's look at the other one. So this one will be set to 1 if and only if RDX minus RCX is greater than 0, which means it's set to 1 if and only if RDX is greater than RCX. And it is, because RDX has the value 2, while RCX stores the value of 1. So this makes sense. Okay, so that's the conditional set instruction. You can read this to see all the different ways you can do. After going through these, the other ones are pretty straightforward. It's just being set based on different conditions. You can set if it's equal, set if not equal, right? Depending on what you want. Set if greater than, set if greater than equal to, less than or equal to. Okay, so I think that's pretty clear now. And let's also cover conditional move instructions. So conditional move, so based on the compare to flag, it will execute the move queue source to destination based on whether or not, for example, if it's equal to or if it's not equal to, which means, for example, for C move E, if it's equal to, then it will move the source S to the destination register D. But if it's not equal to, then equal to would be false, and it's not going to move source S to the destination D. And this could be very useful. Like for example, for if-else statements, you might have to write a lot of labels, a lot of lines of code. You have to use jump to the next, skip a block if it's based on the condition. And maybe you just want to simply move a value using if-else. And a simpler way would just be using conditional move instruction. Okay. So let's take a look at this. So I'm going to get rid of the set instructions. And so let's still use R8 and R9, but let's initialize both R8 and R9 to 3. Okay. And then let's use the conditional move instructions. So we're going to move if RDX minus RCX is less than 0. We're going to move RCX into R8. So if this condition is true, if RDX minus RCX is indeed less than 0, then the value of 1 should be moved into R8. Otherwise, R8 should remain at value 3. Okay, so now let's do C move G, RDX into R9. Okay, so same thing, except with greater than. So we're going to move RDX into R9 if and only if RDX minus RCX is greater than 0. Okay. So we can get rid of these. Just simply move QRA into RSI and move QR9 into RDX, the third argument. Okay. So let's take a look at this. undefined reference to. Okay, I probably made a careless mistake again. Yep, I made the same mistake again. Should be percentage. Okay. Okay, so we see that R8 still remains at the value it was assigned to, remains 3, but R9 changed from 3 to 2, which means that RDX minus RCX is indeed greater than 0, right? Because RDX is 2, RCX is 1. So 2 minus 1 is obviously greater than 0. So, which is why that RDX got moved into R9. So R9 has value 2. But because the less than condition is false, RDX minus RCX is greater than 0, not less than 0. So RCX is not moved into R8. So R8 remains at the value of 3. Okay. I think the conditional move instructions are pretty straightforward. They're very useful, and it can really simplify some of your implementations. Sometimes it's easier to use just a conditional move instead of using if, else, and jumps. So this is very useful. Hello everyone, I'm so glad that you made it to this part in the video. If this is your first time watching my video and really enjoyed it, don't forget to like and subscribe. I make a lot of videos about assembly programming, about algorithms and data structures, and about math. So if you're interested in this stuff, make sure to subscribe.